This video is simply titled Box Plots. It is the work for Thursday. We are on week 9 of online learning. So we are creeping towards the end of the year. We're basically there. So today you will have a Quizizz. If you have not done Wednesday's crime scene activity yet, please go back and do that. And make sure you're keeping up with your tracker and seeking support as needed. Throughout this video, you're going to notice an absence of the notebook and the pencil, signifying taking notes. I'm going to push you guys to take notes as needed. Really, that's how you should always be operating. And when you're thinking what notes do you want to take down, think about the key points, the things I emphasize often, maybe things that are underlined, bolded. But I'm going to push you guys today to take notes when you feel like it is necessary rather than just when I tell you to. So I want you guys to think through that today. All right, so as I said, we are looking at box plots. So we're going to look at this example first. I'm going to scroll down here. Helen wants to display the lengths of 15 fish she caught. She decides to make what's called a box plot. You guys should be familiar with these. This data is organized in this green table here to the right. What a box plot does is it shows distribution or arrangement of data values on a number line. And it uses what's called a box and then what's often called whisker, so you'll hear like box and whisker plot, in order to display this data. Now, to make a box plot, Helen needs to find the median or the middle number first. She needs to also identify the minimum, which is the smallest data value, and the maximum. Those are 3 out of the 5 points we need in order to create a box plot. The median, the minimum, and the maximum. So, let me scroll down here. What I've already done for you is I have organized Helen's data set from least to greatest, because remember, to find the median, you need to first order your numbers, either least to greatest or greatest to least to pick the middle. Now, the median is 13. We covered the median in previous lessons. The minimum is 7. The maximum is 22. Minimum is just the smallest. Maximum is simply the largest. We could also identify things like mean and mode here, and range. But in terms of creating a box plot, all you need is minimum, medium, maximum, and then what's called Q1 and Q3, which we'll get to in a second. Now, after we have lined our numbers up, we have found the minimum, the median, the maximum. 3 out of the 5 data points we need to create a box plot. Helen will have to find the median of each half of the data in order to divide the data ultimately into 4 sections, which are called quartiles. Quart means 4, quartiles means 4 sections. So, what we're doing and what you see in this diagram down here at the bottom is we are splitting first the data in half at this 13 point. Okay, so that creates 2 sides, a 50-50 split of the data, where you have the numbers to the left of the median and the numbers to the right of the median. Then what we have to do is we have to find the middle of the bottom and the middle of the top. So, just to be clear here, after I split this down the middle, what I essentially did is then marked out numbers on the side, on the bottom side first to find 10, which is called Q1, and then did the same thing here to find what is called Q3, which is 15. What you also see here in the boxes is this data has now been split into 4 sections called quartiles, where 25% of the data is contained in each of the 4 quartiles to add to the 100%. Now, when we go to construct our box plot, we now have the 5 pieces of information we need. You're going to need the minimum. You're going to need the first quartile, or Q1. Going to need the median. Going to need the third quartile, or Q3. And you're going to need the maximum. Those are the 5 data points you need in order to create a box plot. this is what the box plot ultimately looks like. And you can pause the video as needed, rewind, whatever you need to do. Remember that. The minimum is indicated with a dot, like this. And this is what's kind of called a whisker here. This part contains 25% of the data, or a quarter of the data. That is a quartile, okay? This is the minimum. What you will also see sometimes is just dots over here by themselves. Those are representing outliers. So those are values that are way too small or way big in terms of the rest of the data. So sometimes you'll just see random dots sitting by themselves on the edges. All right, now this represents the next 25% of our data. Right here, this line in the middle of the box is our median. Okay? This represents our minimum. This is our median. Now, this other part of the box here represents another 25%. And then hopefully you're getting onto this pattern. This last part here represents the final 25%. And what I notice here is the spread or the variability of this final 25%, this upper 25% is actually very large because it expands all the way from 15 to 22. That's a larger distance than any other of my quartiles. Once again, 22 here represents our maximum value. Now looking at this, we can calculate a lot of things. Well, we see our median's 13 visually. We can calculate our range by taking 22 and subtracting away 7 and getting 15. So the range of our entire values is 15. We can look at the range of just this upper quartile here and take 22 minus 15 and get 7. We can take what's called the IQR, which we'll get to in a second, by finding the range of this box by doing 15 minus 10 and getting 5. We have a minimum, we have a maximum. We don't seem to have any outliers here based on our box plot because there's no like dots at way out either towards the greater end or lesser end of our dot plot. Now, as I mentioned, this is just kind of summarizing a little bit neater. You have this first quartile, second, third, and fourth. Each quartile contains 25% of the data, adding together to display the entire 100% of the data. Quart, remember, means 4. Hence, while there are 4 quartiles, because 4 quarters adds to a whole. Now, once again, I'm just re-emphasizing these things. Remember, I mentioned at the beginning. Like if I say something over and over again, it's probably a key point, probably something you want to write down. Now, because each quartile represents 25%, these 2 quartiles in the middle represent 50% or half of the data. So that entire box, the entire box contains half of your data, with 25% coming to the left of this median line, and the other 25% coming to the right of the median line. This box is also called the interquartile range, or the IQR. Highlighted here, you can see in yellow, this represents the interquartile range. Now, 15 here minus 10 is 5, so the interquartile range here, and I'm just noting here and here, would be 5. That does not mean that is the overall range. We know range by itself is just your greatest number, 22, minus your smallest number, 7, to get a value of 15. But IQR just deals with that middle 50% of the data. So make sure you're able to make those distinctions between interquartile range and overall range of a data set. Now, we're going to transition to comparing box plots. Today on your quizzes, you're going to have to go through the task of comparing data. So before I hop forward, I'm just going to look at these and make just some general notices here. First of all, Farmer Adam has the smallest value at 20, right? And the smallest the smallest value for Farmer Baxter is only 36. So it seems like Farmer Adam has the far lesser overall value, and Farmer Baxter has the greatest maximum value. Farmer Baxter also has the greatest median, which looks like it's 41. Farmer Adam's median is only 32. What I also noticed overall is Farmer Adam seems to have more spread of the data. The entire box plot is wider. It expands more numbers, whereas Farmer Baxter's is more condensed, meaning his numbers are much more clumped together. There's more consistency there and less variability compared to Farmer Adam where it's spread out. That's a high level of variability. Farmer Adam has a greater range, also has a greater interquartile range because that box is spread longer. So those are just some basic notices I have from looking at this box plot on this number line. Now, range is the difference between the greatest and least value. Okay, we're going to kind of nail home some observations I made. The range for Farmer Adam is 20 because its maximum value here is 40 minus 20, which is minimum, it's 20. Range for Farmer Baxter is going to be 45 minus 36, which gets 9. Now, interquartile range is a little bit different. We're just talking about the box, the middle 50% of our data. So the IQR for Adam is 12 because 36 minus 24 is 12, whereas the IQR for Baxter is only 6 because 43 minus 37 is 6. Now, variability describes spread. I used that term not 30 seconds ago, maybe a minute ago, whatever it was, but it was recent. Variability can be measured by things like range or interquartile range because both of those values, IQR and range, measure spread. And variability deals with spread. So based on this, Adam has the greater range in IQR, interquartile range, which signifies that Adam's data set has more variability or less consistency, you can phrase it that way, than Baxter's data, which has the lower range and the lower interquartile range. So these are just some important comparisons you will be making in today's quizzes. So that wraps up this video on box plots, okay? We discussed interquartile range. We discussed the 5 things you need to create a box plot: median, Q1, Q3, maximum, and minimum. We discussed some observations you can make. You can calculate IQR. You can calculate range, right? If you know the different parts of a box plot and you know some of that vocabulary that I mentioned in this video, you'll be fine. So now you're going to hop to Quizizz, and you're going to take the Quizizz titled Box Plot. Remember, you have 3 shots to get 80% or higher, and if you need help, just reach out for support.